Okay, what we're looking at is another Heathkit IG102 RF signal generator. And this generator is in fine physical condition. After cleaning it, it has cleaned up remarkably well. Shows very little signs of physical abuse, if any. Nice paint job still, front, back, sides. Just like a minor scratch here on the back. Top is in excellent shape. The handle's in good shape. The front panel, which is the most important part, is in wonderful shape. We've installed the new BNC connectors in place of the button-style mic connectors that originally were on it. And this allows you the freedom to use the newer connectors. Keep your connectors standard for your shop, and allows you to purchase them at a lower rate, instead of having to pay special prices for the antiques, which are often in worse shape. And what we're going to do is we're going to run this thing through some tests to show you that it is in fine shape. We've carefully cleaned all of the pots, all of the switches. We had a pot that was frozen here. That took some work, but and the switch was also very tight. We took care of that. And now it's in really great working shape, and let's take it through some steps and show it to you. At the moment, I have it connected to a B&K 100 megahertz oscilloscope, and we are right now looking at the maximum frequency that this generator will put out, which is in essence something over 110 megacycles. And we can see the display. I'm going to go ahead and turn this light off now that we've had a good look at this generator. It'll make it easier for us to see the scope. All right. So there's the output of our signal generator at a little over 110 megacycles. And as I go ahead and dial this down, we are running right now at 50 millivolts per division, so that's roughly 100 millivolts peak, 200 millivolts peak to peak at the maximum frequency. And as we start to cycle down, you'll see both the amplitude change because the oscillator is more or less efficient at different frequencies, and you'll also see the waveform begin to expand. I'm going to go ahead and put more waveforms on here so that we can see the expansion easier. But what you want to look for, the waveform, any notches, oddness in the waveform. It's not unusual to get something like that, and it's not something that's going to stop you from using the generator, but you don't want too much of it. Okay, we are getting down to the low end of 32 megacycle band. I had to turn my oscilloscope gain up a notch. We are not all that efficient at the low end of the 32 megacycle, but when I go to band E from F, I'm going to find out that I overlap at the 32 on the other end, and I'm more efficient. So right now I'm on the low end of band E. This is at 10 megacycles, and I'm going to sweep upwards. Again, watch the waveform, look for deformation, look for oddities. Now we're actually getting more efficient, so I'm going to go ahead and turn my gain down again on the scope, so we can observe the waveform. We are at maximum output on the generator, and I'm turning the frequency up in band E, which would go up to 32 megacycles. So we're approaching the 32 megacycle end here. Actually, we're getting so efficient that I really feel we should be turning the gain control down on the Heathkit and prevent it from overloading itself. Alright, so there we are at the 32 megacycles, and I go ahead and I'm going to turn down to band D. I'm going to go ahead and turn my oscilloscope down in the time base so that we can see more of the cycles displayed. And okay, I am right now at 11 megacycles, and I'm turning down towards the 3.1 mark. As you can see. We'll get through all of these bands in short time. We just want you to be able to see the output as we do it. We can go ahead and turn up our gain a little bit. Okay. We're going to band C now. This is 1 megacycle to 3.2 megacycles. We are at the 1 end and going to 3.2. Alright, we need to turn our gain up a little bit. Or, I mean, down a little bit on the scope. We're less sensitive. We can show the waveform on the screen, the full waveform. Alright, there we are at 3.2 megacycles on band C. Going to band B, which is 310 kilocycles to 1.1 megacycles. Again, I'm going to turn my time base down so we get more cycles displayed. In fact, there we go. Alright, starting at 1.1 megacycles and dialing down. Alright, we've just hit the 310 kilocycle mark, going to band A. Band A goes from 100 kilocycles to 320 kilocycles. We're going up to the 320 now. It'll be a little bit bright there. And there we go. We've just gone from 100 kilocycles up to 110 megacycles in 6 bands, 6 ranges. And once again, we have maximum signal amplitude at roughly 110 megacycles, and we're looking at 200 millivolts peak to peak. Okay, what we're going to do now is we'll do a couple of spot checks of some frequencies. Okay, what we're showing right now is the frequency of the output of the generator displayed on a Philips frequency counter here in the top. So right now we are at the maximum that the signal generator can put out, which on the band would be 110 megacycles, but 110 is actually a little further back, so we're beyond that. And what we see is that that's actually 116.8. So our maximum frequency is 116 megacycles. Now, let's go down to what looks like it would be 110, which would be right about there. And 110 appears to be 113.25, so it's off by 3.25 on the vernier. Now let's see how we stand mid-range. If we go to roughly 60. There's 60 megacycles on the vernier. what we see is 59.4 on the frequency counter. So 60 and 59.4, relatively close. And let's take ourselves down to the low end of the band, which would be 32 megacycles, which would appear to be right about there. And that 32 is 31.6 megacycles. Okay. We'll go to band E. E is on the outer edge. We should be reading 10 to 32. So if we're at 10 here, we're reading 9.8 out of the counter, which is pretty damn close for a vernier like this. Let's take this up to what would be mid-band. That'd be about 17 right about there, and so there's 17. We are reading 16.7, so 17 is in essence. Now let's go ahead and take ourselves up to the 32 mark. 32 on the vernier. We're reading 30.3. So on the high end of the scale, it's off a megacycle or two, but no big deal. All right, then band D. Band D would be 3.1 to 1.1, which would be this particular band right here. So here's 11 megacycles, right about there, and I'm reading 10.29, so 10.3. We're off by 0.7. Let's take her down to mid-band, which would be about 5.5. That seems to be 5.5 right about there. I'm getting 5.4. And then let's take her all the way down to 3.1. Okay. So 3.1 megacycles, and I am reading 3.057 megacycles. We've gone to kilohertz now, 3058 kilohertz, 3.06 megahertz. 3.1, 3.06, essentially the same thing. Band C, we go from 1, which would be there. That would be 1 megacycle, and we are reading 989.5, 990. So we're 10 megacycles off on the low end here. Let's go to mid-band. Roughly, we'll say 7. This would be 1.7 right here. And we are reading 1.66, so 1.7. And then let's go ahead and take it to the maximum, which would be 3.2, right about there. And I'm getting 3.01, 3.02, about 0.2 megacycles off on that end. Not bad. We are on band B. 1.1, let's see, B would be this inner 3.1. Okay. So there is 1.1 megacycles, and I'm reading 1.04. So we're off 0.06. Take it to mid-band. Let's call it 50, right about there. So that would be 500 kilocycles. Let's excuse me. In the right band, no, right band would be there. There we go. 500 kilocycles right there. And I'm reading 490. Alright, so we're a little off. And then this would be 310 kilocycles, and we are reading 305. Band A, 100 kilocycles. We're getting 98.9 or 99 kilocycles. Go to mid-band, and we would read 170 kilocycles. We're getting 167. And then on the high end, it's 320 kilocycles, right about there. And we are getting 309 kilocycles. So all in all, it's not bad. As far as the tracking goes, you can get within a megacycle or two just by eyeballing it on the vernier. If you have yourself a frequency counter, then you can nail it dead on, but not bad at all. So that would be it. Oh, yes, let's take a look at the modulation capabilities. We hook back up to the oscilloscope again, and there. All right. Modulation out, just a pure sine wave. Modulation in, you can see the modulated waveform, both top and bottom. Waveforms going in and out, fluctuating at the 400 hertz tone that this thing generates. It's using an internal modulator right now. If we wanted, we could an internal oscillator that oscillates at 400. And if we wanted, we could put in an external modulator at this point. Well, you could use say a small preamp with a microphone, for instance. Hook it up this, and you could actually broadcast your voice over radio. And you would see your voice being modulated. I mean, that's possible. If we just wanted to look at the signal that's being generated, we can do that. But we have to turn the frequency way down. And there. That's what our internal oscillator at 400 hertz sort of looks like. Okay. So once again, we want there. We're looking again at the modulated signal. So it's working fine. The coarse attenuator will certainly attenuate the signal. You can see it just did. And when you're on the last step, it becomes ridiculously small. But if you're trying to align a set and you wanted to get the weakest signal possible so you get the maximum alignment, then that's how you do it. There you have it. Thanks for putting up with that. I will provide a nice set of leads with this. It will be It will be a BNC connector with the standard, here we go. I have one right here. So we have the BNC connector with the standard gator clip leads. So a new, nice, fine, very usable piece of test lead that you can adapt to a lot of equipment. So I'll provide one of these with it too. And here we are with the test leads. Nice gator clip leads with a BNC connector on the end. And then the manual. It's a Heathkit manual. Takes you through the build. Provides the schematic diagram, parts list, calibration, usage, the whole shot. So there you have it. That's the unit. Thank you.